All right. There, I got my buttons back. All right, here we go. All right, so here is an airplane. The airplane is flying at 1,200 meters above the ground at a speed of 200 meters per second. It drops a practice bomb that hits the ground after traveling a horizontal distance of 1,310 meters. Oops. Okay. For each changes below, use the choices between I and V to identify what will happen to the horizontal distance the bomb travels while falling compared to the situation above. So you have the horizontal will be greater than 330 meters. It could be less than 3130 meters, but not zero. The horizontal distance could be equal to 3130 meters. The horizontal distance would be zero, or we cannot determine how this change will affect the horizontal distance. So those are your choices. Okay, so either more than, less than, equal to, zero, or you have no idea. Okay. Ah, I see. Okay. I will need to just pull this up in my book real fast because I need the actual questions. All right, I know one of the questions is if you fly, instead of flying sideways, what happens if you fly the plane straight up into the air? Where'd it go? Talk to me. What's going to happen?
Just drop in the spot that you are.
Good. So it's going to fall in exactly the same spot that I am. So that would be 1, 2, 3, 4, or 5.
4.
Good. All right. The next question. There it is. If you triple the speed of the plane, so now it's flying sideways, but it's going 3 times faster, what's going to happen to that horizontal distance?
The bomb?
Yeah.
Or it would triple the distance that it goes to.
Okay, so you're saying that if the plane flies faster, the bomb's going to go farther sideways as well. Okay,
Yeah.
specifically, how much farther is it going to go sideways?
Times?
Sorry, what?
Oh, wait. So not 3 times. Okay.
No, I couldn't hear you. All I heard was times.
I said 3 times faster.
Okay, yes. 3 times
Okay,
faster would give you what?
Or 3 times 3,130 is.
Okay, so 3 times farther. Whatever that is, you just multiply it times 3. Cool. Good. The plane is flying in level flight at an altitude of 1,100 meters. So this is farther down. What are you going to see now? Okay, now for this one, I want you guys to type your answer in the chat. So instead of flying at 1,200 meters, now you're going to fly at 1,100 meters. And what is going to happen? Okay, now in your answer, now that you're saying it is less than that distance, now I want a complete sentence answer, including a why. So not only what is your answer, but I want to know why. All right, let's see what you guys got. Go ahead and hit enter. And then I'm going to critique what you guys have written. So I don't want you to feel like I'm being critical. I don't want you to feel bad, bad about what you wrote at all. The reason why I'm going to do this is because I want you guys to see how to improve. And we've got a long ways to improve, I'm sure, because this is the first time that I'm asking you to do this in terms of physics stuff. So let's just take a look. All right, so Sean says the bomb will travel less distance when the plane is lower in the sky because the time that it has to fall is shorter, meaning it cannot go as far if going the same speed. So good. Sean, the only thing that you're missing is that connection between being lower in the sky and that is causing there to be less time before it hits the ground. So just make sure that you don't miss that piece of the puzzle. Ethan says if the plane is flying at a lower altitude, the distance the bomb will travel will be shorter because the angle of the bomb's horizontal velocity is smaller. Uh, so I feel like Ethan, yes, you're saying that I have to go less far. But I don't feel like you answered the question of horizontally what's happening. So be careful with that.
Felt like I was running out of time,
Okay,
and he
that's fine.
said to put it.
Yeah, that's fine. Okay, Kylie says if the plane was traveling at an altitude less than 1,200 meters, then the dropped practice bomb will cover less horizontal distance because it will take less time for it to reach the ground. Sure, that works. Deegan, it will fall for less time, which results in less distance. Okay. Just remember to go complete sentences. So what's falling for less time? Why is it falling for less time? As well. Peter says the bomb will travel less distance when the plane is lower because fall time is shorter, so it cannot go as far. You're getting there. I think you guys are starting to get the idea, though. The bomb will hit the ground before the plane is overhead because the bomb spends less time in the air. Uh, I'm not 100% sure what you mean by the bomb will hit the ground before the plane is overhead. Because if the plane and the bomb maintain a constant horizontal velocity the whole time, because remember, there's no air, even though that would mean that airplanes can't fly. If you have them both moving at a constant horizontal velocity, then the bomb and the plane will be directly above each other the whole time, even as it's falling. So to go like this. So I don't feel like that quite answered the question. All right. So do you guys kind of see how I'm going to be really nitpicky with these? Okay. So just make sure that you're catching all of the steps. All right, next. If the mass of the bomb is increased, what's going to happen? This one I don't need. Actually, yeah. Let's have you guys do your reasoning for this one, but I'm just not going to pick them apart this time. So type out your reasoning. Is it going to be greater, less than, equal to, 0, or cannot determine if the mass of the bomb is increased? Okay, go ahead and type it out. All right, hit enter. Cool. Yeah, good. All right, so you've got, if the mass of the bomb is increased, it will hit the ground the same if there is no resistance. There would be no change, feather and bowling ball in a vacuum experiment. Good. If the mass of the bomb is increased, then the distance will remain the same because the weight of the object will not change the time that it takes to fall. Good. Um, yeah. All right. That's all the answers I got. Okay, cool. Any questions about that one? All right. And the last one, the bomb is thrown from the plane with a vertical downward velocity of 15 meters per second. All right. You can either just give me 1, 2, 3, 4, or 5, or you can write out your why. Either is fine for this one. All right, hit enter. Woo! Good. Yeah, if you chuck it downwards, it's going to start with a bigger downward velocity, which means that if you're going faster, you need less time to get there. So if you're going, excuse me, so if you're going faster, you're going to need less time, which means that it's going to go a smaller horizontal distance. Great, good. All right, this one's kind of fun. All right, so this one is a little bit tricky because you are going to look at these graphs and you are going to pick which one it is. So each one, 1, 2, 3, 4, and 4 all have different graphs. And I want to look at each one separately. So you're using the coordinate system with up as the positive vertical direction. And to the left as the positive horizontal direction, and with the origin at home plate. Select the graph from the choices below that represent those things. So I'm going to say select a graph. For each. All right. 1, 2, 3, or 4. So let's start with number 1. Horizontal velocity versus time graph. I want you to say A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, or P. So number 1, horizontal velocity versus time graph. You're going to put a letter A through P. Throw it in the chat. I don't care if you're wrong. Good. All right, cool. So you know that it's going in the positive direction because that's to the left in this example. And it's not speeding up or slowing down. Good. All right, number 2. So the correct answer for number 1 is A. So here, I'll write it here for you guys. A. All right. Number 2, horizontal acceleration versus time graph. Beautiful. C is correct. All right. Part 3. Vertical velocity versus time graph. Okay, don't put it in the chat yet. Or you can put it in the chat, but don't hit enter, I guess is what I meant. Uh-oh. Everybody froze. Did I die? Oh, you're back. Okay, good. All right.
Can you explain why it's C, just really quick?
Sure. So the answer is C because horizontally it's going to maintain a constant speed the whole time. Well, if you're not speeding up or slowing down, that means your acceleration is 0. So it's 0. And it's going to stay at 0 because I'm never going to speed up or slow down.
Well, thanks.
Yep. All right. You guys ready to hit enter? I want to see 8 responses when I say hit enter. Hold on. It looks like there's a couple people that aren't sure. Go like this in front of your camera if you're ready to hit enter. Okay, go. Hit enter. Oh, yeah, we've got a discussion that gets to happen this time. Woo! All right. So I saw a D. I have an N, an I, N-I-D-I-I-D-N. Okay, N-I-D-I. Okay, so we've got an N, a D, and an I. Congratulations, last period. Nobody guessed the right answer. This class period, some of you guessed the right answer, so that's good. All right, so let's start with this. What is your starting velocity in the y direction? Positive or negative? Positive, good. Why do you say it's a positive starting velocity?
Because the ball is going up.
Good. And Sean, yes, exactly. It's going up. Okay, cool. So ball is going up at the beginning. That means that it must have a positive velocity. So this one's out. That one cannot be right. Okay. And then you guys said, what is it at the end? It's going down. Is that a positive or negative velocity? Negative. Good. Okay. So that means I have negative velocities. Well, negative velocities live down here in the bottom part of the graph. So that means that there's no way that this one can be right because it ends up with a positive velocity. So here is my answer. So I will be my correct answer for 3. Are we good with that? Okay. Now we need to explain your reasoning. So for explaining your reasoning, oh, sorry. We just did that. I meant vertical acceleration versus time graph. Okay, vertical acceleration, what is it doing? Type in the chat, but don't hit enter. When you're ready. Don't care if you're right. I just care if you guess. I'm ready to go. We have B and N and N and B. All right, so we have B and N as our 2 guesses. So let's take a look. So B and N. All right. How do you know what acceleration is using a velocity versus time graph?
The slope.
The slope. What is the slope of I?
A negative number.
Uh-huh. Does that slope ever change to be positive?
Nope.
Does that slope ever change? Nope. So then B is correct. And is wrong again. All right. Any questions? All right. Cool. How are we doing on time? 2:33. Excellent. All right, so the last thing that I have to do with you guys is I'm going to start going over forces. So we're going to start the next unit. So go ahead and get out something to write with.